Okay, let's take a look at y equals a sine this time, cosine next time maybe, b, open bracket, x minus c, close bracket, plus d. Now your teachers may use h and k or p and q, and probably not p and q, but maybe h and k. So I'm going to start by drawing a graph that I've memorized, and that is sine x. In exactly the order that we've always learned it. Beginning, end, halfway between, halfway between, halfway between. And I'll draw my sine function. I should have marked pi and 2 pi. So we're going to talk about features. Well, we're going to take this and we're just going to enlarge it for a moment. And this is the amplitude. It's always positive. Here it is again. It's always the distance from the horizontal center line to the top or the bottom. And the distance from the start to the end is the period. P equals 2 pi. And above, looking at the formula, b is used to help calculate the period because the formula is p equals 2 pi over b. A formula we're going to do all the time. So, excuse me, always write my formula as y equals sine x, the name of the function. So, we've gotten familiar with sine x in the last section. And I'm going to shrink this back up to 2 by my regular 4 by 4. And we're going to talk about an amplitude change. So the amplitude, let's do, before we did y equals that, sine x, now we're going to do y equals 2 sine x. In the most basic form, y equals a sine x. It's a formula. I'm going to put a box around it. So we now have an amplitude of 2. Well, what is an amplitude of 2? Well, if I have an amplitude of 2, I know that it's vertically expanded by 2, multiplying all the y values by 2. So I'm going to draw a little bit bigger of a graph this time. I'm going to use 8 squares or so. And then a horizontal line, 7 squares, the same horizontal line. And my x-intercepts don't change because if I have a vertical expansion of 2 from chapter 1, x-intercepts are invariant points, so those points would stay the same. But my old point, I'm going to circle it in red in the graph above, has a y value of 1. So now we're going to have a y value of 2. And again, I'm going to circle above the 1, 2, 3, 4th point off to the right at 3 pi over 2 has a y value of negative 1. So I'm going to multiply that by 2 and negative 1, negative 2, and I get negative 2, and I couldn't put a point directly below it at, negative 2. I'm going to solidify this point up at 2 a little bit better. And now I can draw in my function, a sine function, just like that. Where now, I'm going to make this a little bit bigger. My amplitude is now 2. As you can see, the y value on the y-axis is 2. My amplitude has changed. My amplitude here as well is also 2. So lots of the times it's just simpler to do little tiny transformations. In the next coming few chapters, few sections, we're going to see how we really want to use what's called the box model. And I'm going to draw the box around this graph here, and there it is. Notice a little bit bigger. The box has had a vertical expansion equaling 2. Due to this 2 in front. So that's a vertical expansion of 2 for y equals 2 sine x in the form y equals a sine x, which is a vertical expansion. Now let's see another graph. So let's do y equals sine of 2x. Y equals sine of 2x in the form y equals sine bx. I'm going to put a box around that. It's a formula simplified from above with only, I'm above in the formula now, just the b value. We worked on the a value, and now we're just working on the b value. And there's a couple different ways. Well, I'm just going to first draw my regular 4x4 graph because I know that it is just a horizontal compression of a half. So I'm going to do that in big red because I did above. Horizontal compression equaling 1/2. So from the graph above that I've memorized, I'm going to put an arrow coming down from it. All of my points are horizontally compressed by a half. The first point stays because the y value is 0, and if the x value is 0, and if I multiply the x value by a half, I still get 0. And then my point above, in the graph above, at the top, I'm going to circle the point at 2 pi. If I multiply 2 pi by a half, I get pi, so that point goes here. And then if I was careful and I was very attentive watching the last section on graphing, well, halfway in between, halfway in between, halfway in between, and I can draw my sine function. And I could draw another period of it if I wanted to. So notice, now I can't expand this one, I don't have enough space, but now the period, to show one full box, I'm going to do in big red, one full box, is now a period equaling pi. I also, way off to the right in red, could have used the formula P equals 2 pi over B. And I'll circle it in the formula we were working on in big red, y equals 2 sine x. And from the definition of y equals sine bx, we have a b value of 2, so we can substitute 2 in for our b value, and we get a period of pi, as we figured out from graphing. So lots of different ways we can do this interchangeably. Reviewing this page, we looked at the original sine graph. We could have done cosine, obviously, and we looked at vertical expansions. We could have looked at compressions, and we looked at horizontal compressions. We could have looked at expansions. Now we're going to go up and down and left and right.